Hi everyone. Welcome. Welcome back. If you are watching this right now, perhaps it is late where you are. Perhaps the room around you is quiet and dim, and the day has finally come to a soft, slow close. You might be lying down or sitting comfortably, and maybe your eyes are already feeling just a little heavy. That is perfectly fine. That is exactly how this is meant to feel. Tonight, we are going to talk about something that every single human being on this earth has experienced, and yet almost no one fully understands. We're going to talk about dreams, about why we dream, about what happens inside the mind and the brain during those quiet, still hours of sleep. And we are going to take our time. There is no hurry here. There is nothing to memorize, nothing to worry about, nothing to pass at the end. This is simply a place to rest and to gently wonder together. So get comfortable. Let your body settle into wherever you are resting. Take one slow breath in and let it out even more slowly. And let's begin. Slowly, gently. Sleep itself is one of the most mysterious things the human body does. Every single night across the entire world, billions of people close their eyes and their conscious minds slip away. The thoughts of the day begin to quiet. The worries and the plans and the little lists of things to do, they all begin to fade. And something else takes over. We call it sleep. But sleep is not simply darkness, and it is not simply stillness. Sleep is, in many ways, one of the most active and complex states the brain ever enters. And nestled inside sleep, like a secret room inside a house, is the experience of dreaming. Now, if you think back to the last dream you can remember, you might notice something curious about it. The dream probably felt real in some way while you were inside it. You may have been running somewhere, or talking to someone, or standing in a place you recognized from long ago. And within the dream, none of it felt strange. It felt like life. It felt like the present moment. And then, of course, you woke up, and the edges of the dream began to dissolve, like mist in the morning sun. And we can take a moment to notice how strange and beautiful that is. Every night, the brain builds entire worlds. It populates them with people and places and feelings. It creates events that unfold in real time. It generates emotions, sometimes joyful and sometimes frightening, sometimes calm and sometimes deeply moving. And then it lets it all go and returns us gently to waking life. Why does it do this? That is the question we are going to sit with tonight. Slowly, quietly, together. To understand dreaming, we first need to understand sleep itself. Because dreaming does not happen at just any moment during sleep. It has a particular home, a particular phase where it most loves to live. And to find that home, we need to understand how sleep is structured. When you first fall asleep at night, your brain does not immediately go to its deepest, most restful state. It moves through stages. You could think of it like descending a gentle staircase, step by step, going deeper and quieter with each stage. The first stage of sleep is very light. If someone were to gently call your name at this point, you would likely wake up easily. Your thoughts begin to drift and wander. Ideas start to connect in unusual ways. Sometimes, right at the edge of this first stage of sleep, people experience what are called hypnagogic hallucinations. These are very brief flashes of imagery or sound, a face, a word, a quick scene, that appear just as you are crossing the threshold from waking into sleep. Most people have experienced this. You might see a sudden image and feel a small startle, a brief sense of falling, and then you relax again and drift deeper. Slowly, gently, from this light first stage, you move into the second stage of sleep. Here, the brain begins to produce something remarkable, something called sleep spindles. These are brief bursts of very fast brain activity, little electrical rhythms that scientists can see on recordings of brain waves. These flashes of faster activity against the slower, quieter background of sleep. Sleep spindles are thought to play a role in memory, in the way the brain begins to organize and consolidate the things you learned and experienced during the day. We will come back to memory and dreaming a little later, because the relationship between them is fascinating and important. After stage 2, you descend into the third stage of sleep. This is deep sleep. Slow-wave sleep, scientists sometimes call it. The brain's electrical activity slows dramatically. The brain waves become long and rolling, like slow swells on a quiet ocean. At this stage, it is genuinely difficult to wake someone up. The body is deeply relaxed. Growth hormone is released. The immune system becomes more active. Muscles repair themselves. The brain begins its housekeeping work, flushing out waste products that accumulated during the day. This deep sleep stage is when the body does much of its most essential physical restoration. And then, after spending some time in deep sleep, something remarkable happens. The brain does not simply continue to sink further into stillness. Instead, it begins to climb back up. It ascends through the stages again. And when it reaches a certain point in the staircase, something changes. Something shifts. And we enter a state unlike any other. We enter REM sleep. REM stands for rapid eye movement. Scientists first observed this stage of sleep in the 1950s, when a graduate student named Eugene Aserinsky, working with his professor Nathaniel Kleitman at the University of Chicago, noticed something curious happening to sleeping subjects. Beneath their closed eyelids, their eyes were moving, quickly darting back and forth, as if they were watching something, as if something was happening in the darkness behind their closed eyes. Aserinsky woke several of these subjects during these periods of rapid eye movement, and what he found was striking. Nearly all of them reported that they had been dreaming, vivid, detailed, story-like dreams. And when he woke subjects who were not in this stage, who were in the slower, quieter stages of sleep, they reported far fewer or far less vivid dreams, or no dreams at all. This was a landmark discovery. The connection between REM sleep and dreaming had been found. And we can take a moment to notice how long this secret had been waiting to be discovered. Every night for all of human history, every person who had ever lived had passed through REM sleep. Every person who had ever dreamed had experienced this strange state. And yet it was not until the mid-20th century that science found the window through which to look. Now, during REM sleep, the brain does something that seems almost paradoxical. In terms of activity, it looks almost like a waking brain. If you were to look at a brain scan of someone during deep, dreamless sleep, and then look at a brain scan of someone during REM sleep, the REM brain would appear far more active, far more lit up, far more busy. Certain regions of the brain surge with activity during REM. The visual cortex, which processes what we see, becomes very active. The emotional centers of the brain, regions like the amygdala, become very active. The areas responsible for movement, interestingly, also show increased activity. And yet the person is asleep, and their body is not moving. How can this be? How can the brain be so active? How can the visual and emotional and motor regions be firing so intensely, and yet the person remains still and sleeping? The answer is one of the most elegant and protective mechanisms in the entire human nervous system. During REM sleep, the brain essentially paralyzes the body. Not dangerously, not permanently, but very deliberately. The major muscles of the body, the muscles of the arms and legs and torso, are actively inhibited. The signal to move simply does not get through. The brain generates the impulse, the feeling of running or jumping or reaching, but the pathway from brain to muscle is gently, firmly blocked. This is called REM atonia, and it exists, most scientists believe, to protect us, to prevent us from physically acting out our dreams. Slowly, gently, think about what could happen without this protection. If you were dreaming of running, your legs might actually begin to run. If you were dreaming of climbing, your arms might begin to reach and grasp. This would be, at the very least, inconvenient. And at worst, it could be dangerous. There is, in fact, a rare sleep disorder called REM sleep behavior disorder, in which this protective paralysis breaks down. People with this condition do act out their dreams. They may shout or swing their arms or get up and move. It can be alarming to witness, and it can be physically risky for both the person and anyone sleeping nearby. Research into this disorder has also revealed an important and somewhat sobering connection. REM sleep behavior disorder is associated with an elevated risk of certain neurodegenerative conditions, like Parkinson's disease, appearing years or even decades later. This connection has given scientists important insights into what these conditions do to the brain over time. But for most people, most nights, the protective system works perfectly. The brain creates the dream, the body stays still, and the experience unfolds safely in the theater of the sleeping mind. Now, let's think about what is actually happening inside the brain during a dream. When you dream, your brain is generating an experience. Not just images, but sounds, sensations, emotions, a sense of space and time and narrative. It is generating a version of reality. And here is something very interesting to sit with quietly. The brain uses the same neural machinery to generate the dream as it uses to process the real world. The visual cortex, the region that processes sight when you are awake and looking at a tree or a face or a sunset, that same region is active when you are dreaming of a tree or a face or a sunset. The auditory cortex, which processes sound, is active when you dream of hearing a voice or music. The hippocampus, which is involved in memory and navigation, is active in dreams. The amygdala, which generates emotional responses, is very active in dreams, which is why dreams can feel so emotionally charged. And we can take a moment to notice that in some very real sense, the dreaming brain does not know it is dreaming. It is simply experiencing. It is simply processing, generating, feeling. The signals coming in are different, that is true. When you are awake, the signals begin in the outside world. Light hits your eyes. Sound enters your ears. Touch registers on your skin. These external signals drive the brain's activity. In a dream, the signals are generated from within. The brain becomes, in a sense, its own theater, its own light show, its own author and audience both at once. There is a region of the brain called the prefrontal cortex, which sits just behind your forehead, more or less. It is involved in many of the things we think of as distinctly human, things like rational thinking, self-awareness, logical planning, the ability to recognize contradictions and inconsistencies. This region is remarkably active when you are awake. During REM sleep and dreaming, the prefrontal cortex becomes significantly less active. And this, many scientists believe, helps explain something very characteristic about dreams. Something you may have noticed in your own dreams. In a dream, you often accept things that, in waking life, would immediately strike you as strange or impossible. You might find yourself in a house you have never been in, and yet you feel certain it is your childhood home. You might encounter someone who has passed away, and you speak to them naturally, without surprise. You might fly, or breathe underwater, or find that a room keeps extending forever, and none of it triggers the response of your waking mind, which would immediately say, wait, something here does not add up. The critical, questioning, logical voice is quieter in the dream. The prefrontal cortex, with its habit of checking and cross-referencing and raising red flags, is less engaged. And so the dream's internal logic, however different from waking logic it might be, simply unfolds. You accept it. You inhabit it. There is no need to rush. There is a state called lucid dreaming, which is an exception to this pattern. In a lucid dream, the dreamer becomes aware that they are dreaming. They retain enough conscious awareness to recognize the experience as a dream, and sometimes to direct or influence it. Research has shown that in lucid dreams, the prefrontal cortex becomes more active than in ordinary dreams, though still less active than in full waking. The dreamer has, in a sense, switched on a dimmer switch of awareness within the dream. And some people can learn to do this deliberately, with practice and technique. But for most people, most nights, The dream simply unfolds without question, without the filter of logical scrutiny. And that is part of what makes it feel so vivid and so real and so strange, all at once. Now, gently moving forward, let us think about the question of why. Why do we dream at all? What is the purpose, the function, the reason that evolution has given us this nightly experience? This is one of the great unsolved questions in neuroscience. Scientists have proposed many theories over the years, and the honest answer is that we do not yet have a single definitive explanation. But we have some very compelling ideas, and each of them illuminates something true and important about dreaming. Let us explore them, one by one, slowly and carefully, letting each idea settle before we move to the next. And we can take a moment to notice the humility this requires. To look at something so common, so universal, and to say we are still learning. One of the most well-supported theories of dreaming is the memory consolidation theory. The idea that dreams play a role, perhaps a central role, in the way the brain processes, organizes, and stores memories. During the day, you experience things. You learn things. You encounter facts and feelings and events and impressions. Much of this gets temporarily stored in a region of the brain called the hippocampus, which is a curved, seahorse-shaped structure deep in the brain. The hippocampus is like a notebook, capturing the experiences of the day in a relatively raw, unprocessed form. But the hippocampus is small. It cannot hold everything forever. And the long-term storage of memories, the way they become woven into who you are and what you know, requires the memories to be transferred and integrated into the cortex, the outer layer of the brain where knowledge lives more permanently. Sleep appears to be when much of this transfer happens. During slow-wave deep sleep, the hippocampus and the cortex engage in a kind of dialogue. The hippocampus appears to replay the day's experiences, and the cortex listens and integrates. Scientists have observed neurons in sleeping rats firing in the same sequence they fired during the day when the rats were learning a maze, as if the brain is replaying the experience during sleep, consolidating the learning. During REM sleep, something related but different seems to happen. The connections between memories are strengthened and elaborated. The brain begins to find patterns and relationships between things that were learned at different times, drawing unexpected connections, integrating new information with old. And this, some scientists believe, is part of what we experience as dreaming. The dream may be, in part, the conscious experience of this memory consolidation and integration work. As the brain replays, connects, and reorganizes, we experience it as a story, as a scene, as an emotional journey through a landscape made of our own memories and associations. There is a beautiful experiment that illustrates this connection between dreaming and memory. Subjects in various studies have been asked to learn a new skill or a new set of information, and then some of them were allowed to sleep and some were kept awake. Those who slept, and particularly those who entered REM sleep, consistently performed better on the task afterward. The sleep itself seemed to be doing something to help them learn. And even more striking, when subjects were asked about their dreams during the night following learning, those who dreamed of the material they were learning showed the greatest improvement. The dreams were not always literal. Someone learning to navigate a virtual maze might not dream of the exact maze, but of maze-like structures, of getting lost or finding paths, of the feelings associated with navigation. The brain was processing the experience through the language of the dream. Slowly, gently, Matthew Walker, a sleep scientist at the University of California, Berkeley, has described this beautifully. He speaks of sleep as the time when the brain takes the information of the day and performs a kind of alchemy on it, connecting disparate threads, finding meaning in patterns, transforming raw experience into woven knowledge. And dreaming, in this view, is not just a side effect of sleep, but an active and important part of this process. Another theory of dreaming focuses on emotion, on the regulation and processing of emotional experience. Life is full of moments that carry emotional weight. Joy, fear, grief, love, frustration, anxiety, wonder. These emotional experiences can leave traces in the brain, activations of certain circuits and networks that linger long after the event that triggered them has passed. Some experiences are so emotionally powerful that they can leave very deep traces, what we sometimes call emotional wounds or trauma. There is a theory, developed in part by neuroscientist Matthew Walker and others, that REM sleep and dreaming serve as a kind of overnight therapy, a time when the brain returns to emotionally significant memories, but in a different chemical environment than waking. Specifically, during REM sleep, a neurochemical called norepinephrine, which is associated with stress and anxiety, is significantly reduced in the brain. It is present during waking, and it rises during stressful situations, but during REM sleep, it drops to its lowest levels of the entire day. The theory suggests that this is not an accident. By reactivating emotional memories in this low norepinephrine environment, the brain can process the emotional content of those memories while being insulated from the full stress response those memories normally trigger. In a sense, the brain revisits the wound but without the pain, and through this revisiting, the emotional charge of the memory can gradually be reduced. And we can take a moment to notice how compassionate this is in a way. The brain taking care of itself. The brain, even in sleep, gently working through what needs working through. This theory is supported by evidence from research on trauma and PTSD, post-traumatic stress disorder. In people with PTSD, the normal process of emotional memory processing during REM sleep appears to be disrupted. The nightmares that are common in PTSD may represent a failure of this overnight therapy, an attempt by the brain to process traumatic memories that becomes trapped in a loop, unable to complete the process of reducing the emotional charge. And there is some evidence that certain medications that increase REM sleep and reduce norepinephrine during REM can help alleviate PTSD symptoms. The brain's natural process is being supported and extended by external means. Let's think gently about another perspective on dreaming, one that comes not from neuroscience, but from a long tradition of human inquiry into the meaning of dreams. For most of human history, across most of the world's cultures, dreams have been considered significant, meaningful. In many traditions, dreams were believed to be messages from gods or ancestors, or the deep self. The ancient Egyptians had specialized priests who interpreted dreams, and there are records from ancient Mesopotamia, Greece, China, and countless indigenous cultures around the world of dreams being taken very seriously as sources of guidance or warning or revelation. In the Jewish and Christian and Islamic traditions, dreams are described throughout their sacred texts as vehicles of divine communication. In the Hindu tradition, dreaming is described as one of the four states of consciousness, alongside waking, deep sleep, and the ultimate state beyond all three. The dreamtime of Aboriginal Australian culture is one of the richest and most complex understandings of dreaming in human history, a concept that weaves together cosmology and memory and relationship with land into a unified vision. There is no need to rush. These traditions were, of course, working without the tools of modern neuroscience, and yet they were paying very close attention to the experience of dreaming. They were taking it seriously. And many of their intuitions that dreams are connected to memory, to emotion, to the deeper layers of the self, that they can reveal things we did not know we knew, are finding echoes in scientific research. Sigmund Freud, the founder of psychoanalysis, made dreams central to his work. He called the dream the royal road to the unconscious. He believed that dreams express, in disguised form, wishes and fears and desires that the conscious mind suppresses during waking. His specific interpretations are controversial and largely not supported by modern neuroscience. But his fundamental intuition, that dreams give us access to aspects of the mind we do not normally see, that they represent something real and important about inner life, has a kind of truth to it that persists. Carl Jung, who worked with Freud and then developed his own very different approach, went further. He saw dreams as the psyche's attempt to compensate for and balance what is missing or neglected in waking life. He believed dreams communicate in a language of symbols and archetypes, images that carry deep collective meaning. A journey in a dream, for Jung, is not just a trip, but an exploration of the self. A dark figure in a dream is not just a stranger, but an encounter with the shadow, those parts of ourselves we have not yet acknowledged. Now, moving gently forward, let us think about the content of dreams. Not their purpose or their biology, but the actual material that dreams are made of. Dreams are remarkable for their variety. At one end of the spectrum, there are the quiet, almost mundane dreams, where you find yourself doing something ordinary and familiar, walking through a house, talking with a friend, preparing food. These dreams have a texture very close to everyday life. They are not dramatic. They are not symbolic or strange. They are simply the continuation of ordinary human experience in a slightly different medium. At the other end of the spectrum are the wild, impossible, surreal dreams, where logic has dissolved entirely, where one scene melts into another, where you are simultaneously in two places at once, where the rules of physics have been quietly suspended. These dreams feel genuinely different from anything in waking experience. They feel like art or like poetry, or like something from another world entirely. And then there are the vast middle territories of dreaming. The familiar made slightly strange, the ordinary turned subtly wrong, the people you know appearing in the wrong contexts, doing unexpected things, saying words that mean everything and nothing at once. Slowly, gently, research has found some consistent patterns in what people dream about. Most dreams are social in nature, meaning they involve interactions with other people. Most dreams take place in familiar settings, places from the dreamer's actual life, though sometimes altered in ways that feel important. Most dreams carry some emotional charge, more often negative than positive, more often involving frustration or anxiety or fear than joy or pleasure, though positive and joyful dreams certainly occur too. Dreams are heavily influenced by what has been happening in the dreamer's waking life. The day residue effect, as Freud called it, is real and well documented. Elements from recent waking experience, a face seen on the street, a conversation overheard, a piece of music, an unresolved worry, find their way into dreams. And yet the dream does not simply replay these elements. It transforms them, combines them with older memories, processes them through the filter of emotion and association. There is a particular and interesting question about what role our past experiences play in our dreams, specifically the way that childhood memories and early experiences seem to have a special and enduring presence in dream life. Many people report dreaming of places from their childhood long into adulthood, of childhood homes, schools, neighborhoods that they may not have visited or even thought about consciously for years or decades. There is something about the deep emotional patterning of early life that leaves its mark in the dreaming mind in a particularly lasting way. And we can take a moment to notice how the dream preserves things the waking mind forgets. How some part of us carries these places and times with us, not always consciously, but faithfully, night after night. This may be connected to the way memories are consolidated and organized over time. Older, more deeply integrated memories may be more readily accessed by the dreaming brain, which is drawing on the architecture of memory as it processes and integrates new experience. The old and the new meet in the dream, woven together in ways that sometimes reveal their relationship and sometimes obscure it. There is also something deeply moving about the way dreams can restore what waking life has taken away. People who have lost loved ones often speak of dreams as a place where they can meet those they have lost again, where the relationship continues in some form. The person appears, speaks, feels present. And while the dreamer knows on some level that this is a dream, the comfort and the connection feel real. The emotional experience is real. The grief and the love both present at once. Let's move now, slowly and gently, to think about what neuroscience has learned about the specific brain networks involved in dreaming. One of the most important concepts in modern neuroscience for understanding dreaming is something called the default mode network. This is a set of brain regions that become particularly active when you are not focused on any specific external task, when your mind is simply wandering, daydreaming, reflecting, imagining. The default mode network includes regions involved in self-reflection, in thinking about other people's thoughts and feelings, in imagination and narrative. When you are engaged in a demanding external task, focused attention, the default mode network tends to quiet down. But when your attention is not directed outward, it becomes more active. During dreaming, the default mode network is very active. This makes intuitive sense. Dreaming is, in many ways, the ultimate form of inward-directed mental activity. No external task demands attention. The mind is entirely free to generate its own content, to weave its own stories, to imagine and remember and feel. The default mode network is also active during mind-wandering while awake, during the kind of reverie where your thoughts drift from one thing to another, following chains of association, imagining possible futures or revisiting past moments. And there is evidence that this kind of mind-wandering, like dreaming, plays important roles in creativity, in planning, in self-understanding. There is no need to rush. There is a beautiful connection here, if we look for it slowly. The state of dreaming, the state of mind-wandering, the state of deep meditation, and even certain states of creative flow, all seem to share something in common. They all involve a relaxation of the ordinary goal-directed, externally focused mode of thinking. They all involve a kind of opening, a turning inward, a letting the mind move according to its own deeper currents rather than the demands of the surface task. Gently moving forward, let us think about how dreams change across the course of a night's sleep. A full night of sleep typically contains 4 to 6 complete sleep cycles. Each cycle lasts roughly 90 minutes, and each one passes through the stages of sleep, from lighter stages down into deep slow-wave sleep, and then back up into REM. But here is something interesting. The proportion of time spent in deep sleep versus REM sleep changes across the night. In the first half of the night, the cycles contain more deep slow-wave sleep and relatively brief periods of REM. This is when the body is doing much of its deep physical restoration work. In the second half of the night, the balance shifts. Deep sleep becomes shorter and shallower, and REM periods become longer and longer. By the last sleep cycle before waking, a person may spend the majority of that 90-minute cycle in REM sleep. This means that the dreams you have close to waking are, in general, longer, more vivid, and more emotionally complex than the dreams you have earlier in the night. It also means that if you consistently cut your sleep short, going to bed at midnight and waking at 5 instead of 7 or 8, you are disproportionately cutting off the late cycle, extended REM sleep. And this has real consequences, not just for the quantity of dreams, but for the memory consolidation and emotional processing that this REM-rich sleep supports. Slowly, gently, this is worth sitting with quietly for a moment. The way we treat our sleep, the hours we keep, the compromises we make in the name of productivity or entertainment or anxiety, has real effects on the dreaming mind, on the processing mind, on the mind that is quietly doing its essential overnight work. There is a fascinating aspect of dreaming that has to do with time. In particular, the way that dreams seem to exist in their own temporal space, where time does not quite follow the rules we are used to. In a dream, an enormous amount can seem to happen in what turns out to be a very short period of actual clock time. A dream may feel as if it covers days or weeks, with multiple scenes and settings and events, and yet the REM period it occupied may have lasted only 10 or 15 minutes. Conversely, there are moments in dreams where time seems to stretch very long, where a single interaction or a single scene seems to unfold with unusual slowness and detail. The brain's sense of time during dreaming is not anchored to the external clock. There is no ticking, no light shifting, no hunger building at regular intervals to give the brain its temporal reference points. The dreaming brain generates its own sense of time, and that sense is plastic and variable, expanding and contracting according to its own internal logic. And we can take a moment to notice that this, too, connects to something we experience in waking life. Time does not always feel the same. Time with someone we love can pass in what feels like moments. Time in a waiting room can feel endless. The brain's experience of time is always, to some degree, a construction, a narrative, an interpretation of signals. And in dreams freed from external anchors, this construction becomes fully visible. Let us think now about animal dreams. We are not the only animals who experience REM sleep. Scientists have observed clear REM sleep in all mammals that have been studied, and in birds as well. Dogs and cats are perhaps the most familiar examples. If you have ever watched a dog sleep, you have probably seen them twitch or let out small sounds or paddle their paws as if running. This is occurring during REM sleep, and it is generally thought that yes, they are dreaming. The protective paralysis of REM autonomia is not completely perfect in all animals, just as it is not completely perfect in humans. Enough motor activity gets through to produce those small twitches and movements. And interestingly, research with rats has shown that when the mechanism that suppresses movement during REM is experimentally disabled, the rats do appear to physically act out behaviors that correspond to what their neurons are doing during REM, behaviors that look like running or exploring, the kinds of activities the rats engage in while awake and learning. This is strong evidence that animals dream of their experiences, that their brains, like ours, replay and process the events of the day during sleep. There is no need to rush. What does a cat dream of? We cannot know precisely, but we can reasonably guess that it dreams of the things it does and the world it knows. Of hunting, of warmth, of familiar faces and smells. The same memory consolidation and emotional processing that shapes human dreams likely shapes animal dreams as well. We share this with them. This nightly retreat into the inner world, this rebuilding of the day's experience in a new form. Even birds show REM sleep and are believed to dream. There is particularly beautiful research showing that some songbirds rehearse their songs during sleep. The neurons that control their singing fire during REM in patterns that correspond to the songs they are learning, silently singing in the sleeping brain. The dream as rehearsal. The dream as practice. Now, let us gently consider something that many people find puzzling and sometimes troubling about dreams. Nightmares. Nightmares are dreams with intense, negative emotional content. Fear, dread, helplessness, horror. They are common, particularly in childhood, and most adults experience them occasionally throughout their lives. They tend to occur preferentially in REM sleep, and they tend to occur in the second half of the night, when REM periods are longest. From the emotional processing perspective we discussed earlier, nightmares can be understood as an attempt by the brain to process emotionally intense or difficult material. The brain is working with something that carries a heavy charge: fear, danger, threat, loss. And while the dream is the brain's attempt at processing, when the emotional content is overwhelming, when the material is too intense or too unresolved, the process can break down. The dream becomes caught in the emotional experience without achieving resolution. And the result is the nightmare, an experience of fear and distress powerful enough to wake the sleeping person. Slowly, gently. In children, nightmares are particularly common and are considered a normal part of development. Children are learning about the world at an extraordinary rate. They are encountering new experiences, new information, new emotional challenges constantly. Their brains have a great deal of processing to do. And the themes of childhood nightmares, monsters, being chased, being lost, being separated from parents, reflect the developmental anxieties of childhood, the deep fears that come with being a small and vulnerable creature in a large and sometimes scary world. For most children, nightmares decrease as they get older, as the accumulated emotional and cognitive architecture of experience becomes more stable, more resilient, more able to process difficult material without being overwhelmed. For adults, nightmares are often connected to stress, to anxiety, to unresolved difficulties. Times of great challenge, of loss, of transition, tend to produce more nightmares. This can feel like being punished by sleep itself, like having difficulty follow you even into the night. But it may be, in part, the brain's intensified attempt to process material that is particularly demanding. Recurring nightmares, or recurring dream themes that appear across many years of life, are a particularly interesting phenomenon. The dreamer may return again and again to the same basic scenario: being back in school, unprepared for an exam, teeth falling out, being unable to move or speak when in danger, flying, being in a house that keeps revealing new rooms. Some of these themes are remarkably universal. Research across different cultures and different populations has found that certain dream themes appear with striking regularity in people who have no shared culture or language or life circumstances. Being chased, falling, being exposed or unprepared, flying, meeting the dead. This universality suggests that these themes connect to something deep and broadly human. Perhaps to the common emotional architecture we all share, the universal fears and desires and developmental challenges that come with being human. Perhaps to something even deeper, to the evolutionary heritage of our species, the remnants of ancient fears and ancient hopes encoded in the structure of the brain itself. And we can take a moment to notice how connected we are through this. How the person sleeping in a city on one side of the world and the person sleeping in a village on the other side may tonight visit the same strange territory of the dreaming mind. Let's take a quiet moment to think about creativity and dreams. The dreaming mind has a quality that the waking mind often lacks: a freedom from conventional logic, a willingness to make connections that the waking mind would dismiss as too strange or too unlikely. The normal filters of rational thinking are quiet, and sometimes in this freedom, something genuinely new emerges. There are famous stories of creative breakthroughs that came through dreams. The chemist August Kekulé is said to have discovered the ring structure of benzene after a dream in which he saw atoms forming chains that then curled into a snake biting its own tail. The image, bizarre and symbolic, pointed him toward the answer his waking mind had been circling around. The mathematician Srinivasa Ramanujan, one of the most brilliant mathematical minds of the 20th century, spoke of dreams as a source of his mathematical insights. He described a goddess appearing to him in dreams and writing equations on a tongue of blood, equations that he would wake and write down, equations that proved to be mathematically significant. Paul McCartney has said that the melody for the song Yesterday, one of the most covered songs in the history of popular music, came to him in a dream. He woke with the melody fully formed in his mind, worried it was something he had heard before, checked with friends and musicians, and eventually satisfied himself that it was genuinely new. It had come from the dreaming mind. There is no need to rush. Whether or not these stories are fully accurate in every detail, they reflect something real about the relationship between dreaming and creativity. The dreaming mind makes connections that the waking mind misses. It crosses boundaries that waking logic enforces. And sometimes those unexpected crossings reveal something true or beautiful that would otherwise have remained hidden. Scientists studying creativity have found that people are better at solving certain kinds of problems that require insight and lateral thinking after a period of sleep, particularly after sleep that includes REM. The brain has been, in a sense, reshuffled. New connections have been drawn. Things that seemed unrelated have been brought into contact. And the answer, which was always present in the information available, suddenly becomes visible. Gently moving forward, let's explore something that science is only beginning to understand: the relationship between the gut and the dreaming brain. It may seem strange to bring the gut into a conversation about dreams, but there is an emerging field of research that is revealing how deeply connected the brain and the gut are, and how this connection may influence even our sleeping and dreaming experience. The gut has its own extensive nervous system, sometimes called the enteric nervous system, or informally the second brain. It contains hundreds of millions of neurons, more than either the spinal cord or the peripheral nervous system. And there is a constant bidirectional communication between the gut and the brain, carried through a nerve called the vagus nerve, which runs from the brainstem all the way down to the abdomen, carrying signals in both directions. The gut also produces many of the same neurotransmitters that the brain uses, including around 90% of the body's serotonin. And serotonin is deeply involved in the regulation of mood, sleep, and REM dreaming. Changes in the gut microbiome, the vast community of microorganisms that lives in the digestive system, appear to influence the production of neurotransmitters and the functioning of the nervous system in ways that are still being mapped. Slowly, gently. This is a young field of research, and we should hold these ideas with appropriate gentleness, recognizing that there is much still to learn. But the emerging picture is one of the dreaming mind as embedded in a much larger biological system, connected to and influenced by processes happening throughout the body, in ways we are only beginning to appreciate. Let us now think about the cultural history of dreaming in a slightly different way. Not just what cultures have believed about dreams, but how they have used them. Many indigenous cultures around the world have traditions of what might be called dream sharing, the communal practice of telling and interpreting dreams within a group. In some of these traditions, dreams are not considered private property, but are shared openly with family or community, discussed, interpreted collectively, woven into the ongoing story of the community's life. The Iroquois nations of North America had complex dream interpretation practices and believed that dreams expressed the hidden wishes of the soul, wishes that needed to be fulfilled in waking life. When someone had a significant dream, the community would sometimes take elaborate steps to fulfill the symbolic wish expressed in the dream, to honor what the soul was asking for. The Sainwa people of Malaysia, described though perhaps somewhat romantically in some early anthropological accounts, were said to have a dream culture in which children were taught from an early age to work with their dreams, to face frightening figures in dreams and demand gifts from them, to dream social situations with positive outcomes. While some of the claims about this culture have been contested, the idea underlying it, that we can cultivate a more intentional relationship with our dreaming mind, has found resonance in modern work with lucid dreaming and dream therapy. And we can take a moment to notice how much wisdom was embedded in these traditions, how much careful attention to the inner life was woven into cultures that had no EEG machines, no sleep labs, no neuroscience, and how that attention may have nurtured something valuable, something we are perhaps only now, through science, beginning to rediscover. There is a beautiful and somewhat mysterious phenomenon called the hypnopompic state, which is the complement to the hypnagogic state we mentioned earlier. The hypnagogic state is the transitional state between waking and sleeping, the threshold you cross as you fall asleep. The hypnopompic state is the corresponding threshold on the other side, the transition between sleeping and waking, as you come back into consciousness. During the hypnopompic state, as the brain reemerges from sleep, it can still be carrying elements of dream experience. Images, sounds, sensations from the dream may persist briefly into the waking moment. The boundary between the dream and waking reality is temporarily permeable. Many people, in this hypnopompic state, experience something quite vivid. They may briefly see figures or patterns or scenes in the room around them that are not actually there, overlaid on their visual perception of the real environment. They may hear sounds or voices. They may feel a strong physical sensation of movement or of touch. There is no need to rush. Some researchers believe that many historical accounts of supernatural experiences, of seeing ghosts or angels or presences at the moment of waking, may be rooted in hypnopompic experiences. The mind, still carrying dream imagery, briefly projects it into the perceived real world. The experience feels utterly real, and it is, in a sense, entirely real as an experience. The brain is generating it with full conviction. What it is not is an accurate report of the external world. This is a gentle reminder of something important. The brain's model of reality is always, to some degree, a construction. It is built from incoming signals, from memory, from expectation, from attention. And in those liminal moments between sleep and waking, the construction can become visible in unusual and sometimes beautiful ways. Now, let's gently think about what happens when we remember or fail to remember our dreams. Most dreams are not remembered. Research suggests that even if you dream every night in every REM period, you will typically remember only a small fraction of those dreams, and often only the most recent one before waking, and even that may fade very quickly. The process of moving from sleep into waking is, neurologically speaking, a transition between very different brain states. And during this transition, the information encoded in the dreaming mind does not always make it successfully into the structures needed for long-term memory storage. The hippocampus, which plays a central role in transferring experiences into memory, is in a different mode during dreaming than it is during waking. The chemical environment of the brain changes, and the information of the dream, which felt so vivid and real just moments ago, simply does not get written into the lasting record. Slowly, gently. This is why people who wake gradually, who spend time in a half-awake state before fully rising, often remember more of their dreams. The slow transition gives the dreaming mind more time to connect with the waking memory systems, to write the experience into a form that can be recalled. Keeping a dream journal, waking and immediately writing down whatever you can recall before the images and feelings fully dissolve, is one of the most effective ways of increasing dream recall. People who do this consistently often report a gradual increase in their ability to remember dreams over time, as if the practice of paying attention trains both the dreaming mind and the waking mind to take better note of the experiences at the threshold. There is something touching about this. The dreams we cannot remember are still there, still happening, still doing their work. The brain is processing, integrating, preparing, whether or not the waking self takes note. The orchestra plays through the night, even when the listener is not conscious of hearing it. Let us drift now, gently, to think about a particular kind of dream that sits at an interesting intersection of sleep and waking. The daydream. Daydreaming is not, technically, dreaming in the sleep science sense, but it occupies a related territory. When you daydream, when your attention withdraws from the external world and begins to wander through internal landscapes of memory and imagination, the brain enters a state that has real similarities to the dreaming state. The default mode network, which we discussed earlier as being active during night dreaming, is also very active during daydreaming. The same regions that generate dream imagery and dream narrative are engaged in daydreaming as well, though with the difference that the waking brain maintains a higher degree of prefrontal involvement, a higher degree of self-awareness and voluntary direction. Research has found that people spend a remarkable amount of their waking time in states of mind wandering. Estimates vary, but many studies suggest that somewhere between a third and a half of waking time involves mind wandering, thoughts that are not directly related to the present task or the present environment. And we can take a moment to notice that this is not time being wasted. Mind wandering is when many important mental processes happen, when plans form and are evaluated, when social situations are rehearsed and understood, when memories are revisited and processed, when creative ideas emerge. The wandering mind is a working mind, even when it does not look like it. And in this sense, it is not so different from the dreaming mind, which also looks still and quiet from the outside, while inside it is engaged in its own essential labor. There is a condition called sleep paralysis that is worth understanding, because it is a common experience and it can be frightening if a person does not know what it is. Sleep paralysis occurs when a person wakes up, but the REM atonia, the muscle paralysis that protects us from acting out dreams, has not yet lifted. The person is conscious, aware of their surroundings, but unable to move. The paralysis can last from a few seconds to a few minutes, and during that time, the person may still be experiencing remnants of dream imagery, which can be projected into the perceived environment. This can produce very frightening experiences. People in sleep paralysis often describe feeling a presence in the room, something threatening or heavy. Sometimes they report seeing a figure or feeling a weight on their chest, unable to breathe or cry out. These experiences are deeply real as experiences. The brain is generating them with full conviction, in a state that is neither fully asleep nor fully awake. Sleep paralysis is experienced across cultures, and the specific imagery it produces tends to be interpreted through the cultural lens of the person experiencing it. In different cultures and different periods of history, the figure perceived during sleep paralysis has been interpreted as a demon, a ghost, a succubus or incubus, an alien being. The experience is the same. The interpretation reflects the cultural context. Slowly, gently, understanding sleep paralysis as a neurological phenomenon, as a glitch in the normal machinery of waking from REM sleep, can reduce much of the fear it produces. If you know what is happening, if you know that you are in a temporary state between sleep and waking, that the paralysis will pass in moments, that the perceived figure is a product of the dreaming mind encountering the waking world, you can approach it with curiosity rather than terror. And interestingly, some experienced lucid dreamers report being able to use sleep paralysis as a gateway into a lucid dream, intentionally relaxing into the paralysis and allowing the dream to deepen rather than struggling to wake up fully. Gently moving forward, let's consider how dreams have influenced art and literature and culture throughout human history. The dream as a setting and a device is one of the oldest literary and artistic traditions. Ancient texts from across the world include dream sequences as moments of revelation, instruction, or encounter with the divine. The Epic of Gilgamesh, one of the oldest surviving literary works, contains significant dream sequences. The Bible includes numerous dream accounts. The Iliad and the Odyssey feature dreams sent by the gods. In more recent literature, dreams have served as a space of exploration and revelation. Dante's Divine Comedy is, in a sense, an extended dream vision, a journey through the afterlife undertaken in a state between sleep and death. Shakespeare's A Midsummer Night's Dream takes place in a liminal, dreamlike space where ordinary rules and relationships are suspended and transformed. In the Romantic period, dreams became a central metaphor for the unconscious creative power, for the depths below the ordinary surface of consciousness. There is no need to rush. The surrealist artists of the 20th century, Salvador Dali, René Magritte, Max Ernst, drew explicitly on dream imagery, on the logic-defying juxtapositions and transformations of the dreaming mind, to create art that accessed something that ordinary waking representation could not reach. They wanted to show the inner world, the world of desire and fear and imagination, with the same directness that realistic art shows the outer world. Cinema, too, has always had a deep relationship with dreaming. The darkened theater, the passive viewing, the unfolding of images in time without requiring any action from the watcher, creates an experience with genuine similarities to the dream state. And filmmakers from the very beginning have used this to create experiences that blur the line between film and dream, that ask the viewer to inhabit a world that follows different rules. The shared architecture of the dreaming mind, the universal themes and images that appear across cultures and times, makes dreaming not just a personal experience, but a cultural one. Our dreams, however private and individual they feel, connect us to the full depth and breadth of human experience. Let us now return to the science and consider some of what we know about the neurotransmitters, the chemical messengers that regulate dreaming. During REM sleep, the brain's chemical environment is quite different from both waking and non-REM sleep. Understanding these changes helps us understand the particular quality of dream experience. Acetylcholine, a neurotransmitter involved in arousal, attention, and memory, is at high levels during REM sleep. This may contribute to the vividness and the emotional intensity of dreams, to the sense that the dream experience is fully real. Serotonin and norepinephrine, neurotransmitters associated with mood regulation and alertness, are at very low levels during REM. This may contribute to the quality of dreaming that allows bizarre connections and transformations without triggering a critical response, the quality that lets the dream follow its own internal logic without interruption. Dopamine, associated with reward, motivation, and the brain's systems for seeking and desire, is involved in dreaming in complex ways. Some research suggests that the bizarre and unexpected elements of dreams may be related to the dopamine system, which is involved in predicting and responding to novelty and surprise. And we can take a moment to notice what a rich chemistry the dreaming mind is immersed in. Not chaos, but a very specific and carefully regulated chemical environment, one that creates the particular qualities of dream experience as precisely as a chef combines ingredients to create a particular flavor. Medications that affect these neurotransmitter systems, antidepressants, sleep medications, many common drugs, can profoundly affect dreaming. Some medications suppress REM sleep, reducing or eliminating dreams. When people stop taking these medications, there is often a REM rebound, an intensification of REM sleep and dreaming as the brain compensates for what was suppressed. This REM rebound can produce very vivid and intense dreams, sometimes disturbing ones. Alcohol is another substance that affects dreaming. Alcohol initially helps people fall asleep, but it suppresses REM sleep, particularly in the first half of the night. As the alcohol is metabolized and its effects wear off in the second half of the night, there is often a REM rebound, with disturbed, fragmented sleep and more intense dreaming. This disruption of the dream architecture is one of the many ways that alcohol, even in moderate amounts, compromises the restorative quality of sleep. Now, there is something deeply interesting about the relationship between dreaming and the sense of self. Between the dreaming mind and the identity, the continuous narrative of who we are. In most of our waking life, there is a sense of continuity, of being a consistent self across time. This continuity is not entirely accurate, of course. We change, we grow, we contradict ourselves, we are different in different contexts. But there is a felt sense of being a self, a character with a consistent perspective and identity. In dreams, this selfhood becomes more fluid. You may inhabit a perspective that is not quite your own. You may observe yourself from outside, as if watching someone else. You may shift between perspectives within a single dream. The boundaries of the self, which feels so fixed in waking, become permeable in the dream. Slowly, gently, this fluidity can be disorienting when we reflect on it after waking. If I was someone else in my dream, was that still me? If I did something in a dream that I would never do in waking life, does that reveal something about who I am? These are not just philosophical puzzles. They connect to genuine questions about the nature of identity, about what the self is and where it lives. Some perspectives on the self, drawn from both contemplative traditions and from certain currents in philosophy and neuroscience, suggest that the self is not a fixed thing but a process, a continuous act of narrative construction. The brain is always generating a story of who we are, and that story draws on memory and experience and expectation. And the dream is, in a sense, another instance of this story-generating process, running on a different substrate, with different rules and different characters. Let's think for a moment about a fascinating question. Do blind people dream? Yes, blind people dream, but the content of their dreams depends on when they lost their vision. People who were born sighted and became blind later in life often continue to experience visual imagery in their dreams, sometimes for many years after losing their vision. The visual cortex, trained by years of visual experience, can still generate visual imagery in the absence of external input. Dreams maintain the visual world that was once known. People who were born blind or who lost their sight very early in childhood, before visual experience could be consolidated, do not typically have visual dreams. Their dreams are experienced through the other senses: touch, sound, smell, taste, movement. They are just as rich, just as vivid, just as emotionally full as sighted people's dreams. But the sensory modality is different, shaped by the sensory world the brain was built on. And we can take a moment to notice how perfectly this illustrates that dreaming is not fundamentally about vision or about any particular sense. It is about experience. It is the brain generating experience from its own resources, drawing on whatever architecture of experience it has built. The dream is made of what we know and what we feel, whatever form that takes. There is a theory of dreaming called the threat simulation theory, developed by Finnish cognitive neuroscientist Antti Rauvansio. It proposes that dreaming evolved, at least in part, as a kind of rehearsal for threatening situations. In this view, the dreaming mind is a simulator. It creates scenarios that involve danger, threat, challenge, the need to act under pressure. And by running these simulations repeatedly over the course of a lifetime of nights, it trains the brain and, to some limited extent, the body, in how to respond to threatening situations. The high proportion of threatening and anxiety-inducing content in dreams, compared to the relative positivity of waking life for most people, is cited as support for this theory. The dreaming mind seems drawn to difficulty, to challenge, to things that require responses. And this may not be a malfunction but a feature. There is no need to rush. Think of the way that nightmares so often involve being chased, being threatened, being in danger. Think of the way that anxiety dreams of being unprepared or exposed or trapped, are so common and so emotionally intense. If the dreaming mind is a threat simulator, it makes sense that it would work hardest at the scenarios where the emotional cost of being unprepared would be highest. This theory connects interestingly to the observation that children have more frightening dreams than adults. Children are in the stage of life where the world is most new and most full of genuine unknowns, where the need to learn how to navigate threatening situations is highest. The simulation, in this view, is working hardest precisely when it is most needed. Gently, let us think about a question that lives at the intersection of neuroscience and philosophy, and perhaps deeper. The question of consciousness. What is the relationship between dreaming and consciousness? What does it mean to be conscious? And what does the fact of dreaming tell us about the nature of conscious experience? During a dream, there is experience. There is something it feels like to be in the dream. There are colors and sounds and sensations and emotions. There is a perspective, a point of view, even if it is not perfectly anchored to the waking self. By any reasonable definition, the dreaming mind is conscious. It is having experiences, and yet the information coming in from the outside world is largely blocked. The dreaming brain is generating its experience almost entirely from within. It is conscious, but its consciousness is not oriented toward external reality. It is turned inward, generating its own world. Slowly, gently. This is philosophically fascinating. The question of what consciousness is, of what produces the felt quality of experience, what makes red look red and pain feel painful and joy feel joyful, is one of the hardest questions in philosophy and science. It is sometimes called the hard problem of consciousness, and dreaming is one of the most interesting data points in this puzzle. It shows that consciousness, that the felt quality of experience, does not require accurate input from the external world. The brain can generate rich, vivid, emotionally full experience entirely from within its own activity. The external world is not the source of consciousness. It is one of the inputs to a system that generates consciousness, but the system can run without it. This connects to questions about perception that are fascinating to sit with quietly in the late-night hours. Even in waking life, the world we perceive is not the external world directly. It is a model of the external world, constructed by the brain from incoming signals and shaped by memory, expectation, attention, and emotion. The model is usually a very good fit to the external world, because survival depends on it being a good fit. But it is still a model. It is still a construction. Dreaming reveals the construction. It shows us the brain building its model without external input, and we can see in the dream the seams and joints of the construction process, the way memory and emotion and imagination contribute to what feels like direct experience. And we can take a moment to notice how quiet everything has become. If you have been following along, perhaps you have felt the weight of your eyes growing heavier. Perhaps the words have been washing over you like a slow, warm current. Perhaps the ideas have been floating past like leaves on a dark river, each one interesting, each one allowed to pass without needing to be grasped. That is exactly the right way to be here. Let us drift a little further. Let's think about what it means that we have been dreaming for as long as we have been human. Longer, perhaps, since our primate ancestors and their mammalian ancestors before them were experiencing REM sleep long before our species appeared. Dreaming is ancient. It is older than language, older than civilization, older than writing and art and music, though not perhaps older than some of the impulses that led to those things. Every human who has ever lived has dreamed. The cave painters who made the extraordinary paintings at Lascaux and Altamira, who worked by firelight thousands of years ago, covering stone walls with horses and bison and handprints, they dreamed. The ancient astronomers who mapped the stars, who tracked the movements of Jupiter and Saturn with painstaking observation over lifetimes, they dreamed. The builders of Stonehenge, of the pyramids, of the temples of Angkor, what they dreamed. The farmers and the sailors and the midwives and the philosophers, they all dreamed. And they did not know, any of them, what was happening in their brains during those hours of sleep. They did not know about REM cycles or the amygdala or neurotransmitters or memory consolidation. But they felt the dreams. They remembered fragments in the morning. They talked about them, painted them, wrote about them, built entire cosmologies around them. There is no need to rush. The science we have discussed tonight does not diminish the mystery. If anything, it deepens it. To know that the brain generates an entire inner world each night. To know that the same neural machinery that processes waking reality is generating dream reality. To know that this process is ancient and universal and essential. To know all this is to be more amazed, not less. Let's think about one more aspect of dreaming that scientists are beginning to understand: the role of dreams in problem solving. There are many reported cases and some experimental evidence for what is sometimes called insight sleep, the phenomenon of going to sleep with an unsolved problem and waking with a solution, or at least with a new perspective that makes the solution more accessible. We mentioned creative breakthroughs already, but the connection between sleep and problem solving goes beyond famous individual cases. In experiments, people have been given mathematical problems that can be solved by a tedious step-by-step method, but that also have a hidden shortcut that makes them much easier. After a night of sleep, a significantly higher proportion of people discover the shortcut compared to people who worked on the problem without sleeping. The sleeping brain seems to find the shortcut that the waking, step-by-step brain misses. It restructures the problem, sees it from a different angle, finds the hidden path through. This may be related to the way REM sleep promotes the integration of information across different memory systems, the drawing of connections between things that were previously stored separately. The problem and the solution exist in the brain, in different memory traces, encoded at different times. Sleep brings them together, and the result, experienced upon waking, feels like sudden insight. Slowly, gently. This is practical knowledge in a gentle way. It suggests that sleeping on a difficult decision or a challenging problem is not procrastination, but a genuine cognitive strategy. It is giving the brain's deeper processes the time and space they need to work. The dreaming mind, allowed to roam freely through the landscape of memory and association, sometimes finds what the wakeful, focused, effortful mind cannot. Let us take a quiet moment to think about something called prospective memory, which is the memory for things you intend to do in the future. I need to call someone tomorrow. I must remember to water the plants. I want to bring up that idea at the meeting on Friday. Interestingly, sleep, and particularly REM sleep, appears to be involved in prospective memory as well. People who sleep after encoding a future intention are better at remembering to carry out that intention at the right time, compared to people who remained awake between encoding and the time of the intended action. This is another thread in the larger story of sleep and memory, another way that the dreaming mind is not simply shutting down but actively preparing. Preparing not just the record of the past, but the readiness for the future. Slowly, gently, the sleeping brain is, in a sense, setting itself up for the next day, consolidating what was learned yesterday so it can be used tomorrow, processing the emotions of today so they are more manageable tomorrow, rehearsing, integrating, preparing, and doing all of this in the quiet and the dark, without any need for the conscious self to supervise or direct. Now, let's think about something that happens at a cellular level during sleep, something that has only relatively recently come to light and has genuinely changed the way scientists think about why we need to sleep. Inside the brain, there is a system called the glymphatic system. The name combines glial, referring to the glial cells of the brain, and lymphatic, the system in the rest of the body that drains waste products. The glymphatic system is the brain's own waste clearance mechanism. During sleep, particularly during deep slow-wave sleep, the cells of the brain actually shrink slightly, and the spaces between them expand. And through these expanded spaces, cerebrospinal fluid flows much more actively than during waking, washing through the brain tissue, flushing out metabolic waste products that accumulated during the day's neural activity. Among the waste products cleared by this process are proteins associated with Alzheimer's disease, including a protein called amyloid beta, which accumulates in plaques in the brains of people with Alzheimer's. The discovery that sleep is when the brain clears these potentially harmful proteins has given new urgency to the relationship between chronic sleep deprivation and the risk of neurodegenerative disease. And we can take a moment to notice that this is not abstract or remote. This is happening right now, tonight, in the brains of everyone who is sleeping. This gentle, essential cleaning, this slow tide of cerebrospinal fluid washing through the sleeping brain, clearing the residue of the day's thinking. It is one more piece of the picture of sleep as active, essential, irreplaceable. Not passive absence, but vigorous biological work. There is something interesting to think about regarding the way the dreaming brain relates to the sense of smell. Smell, among the senses, has a unique anatomical pathway. The olfactory nerves, the nerves that carry smell signals from the nose, project directly to the hippocampus and the amygdala, the brain regions most associated with memory and emotion. They do not pass through the thalamus, the brain's central relay station, the way signals from the other senses do. This direct connection is why smells are so powerfully tied to memory and emotion. A single whiff of a particular perfume, or of bread baking, or of salt water, can transport you instantly and vividly to a specific past moment, with the emotional texture of that moment intact, in a way that seeing a picture or hearing a description rarely can. In dreams, smell is rarely a prominent feature. Most people rarely dream of smells, and when they do, the smells are often not as vivid or central as the visual and emotional content. This may relate to the particular pattern of activation in the dreaming brain, which tends to strongly engage the visual cortex and the emotional centers, but not always the olfactory areas with equal intensity. There is no need to rush, and yet the connection between smell and memory and emotion is deeply relevant to dreaming, because the structures that smell most directly connects to, the hippocampus and the amygdala, are among the structures most active and most important during dreaming. The emotional and memorial core of the brain, where smell has always had its most direct address, is exactly where dreaming does much of its most essential work. Let us think gently about what is known about the dreams of people who are born with synesthesia. Synesthesia is a condition in which the stimulation of one sense automatically and involuntarily produces an experience in another sense. A person with synesthesia might perceive specific colors when they hear music, or see shapes when they taste food, or experience specific spatial layouts when they think of numbers. It is not metaphor or imagination. For synesthetes, these are genuine perceptual experiences, consistent and involuntary. About 1 in 25 people have some form of synesthesia, making it not as rare as one might think. And interestingly, it appears to run in families, suggesting a genetic component. For synesthetes, dreams are often described as particularly vivid and rich. The additional channels of perception they experience in waking life are often present in dreams as well. A synesthete who sees colors with sounds may dream in music that is also color, in a world where the senses are more deeply interwoven than they are for most people. This gives us a small window into the extraordinary variability of inner experience. The world is not experienced the same way by all humans, even among humans who share the same sensory organs and the same basic neural architecture. The brain's construction of experience is a deeply personal process, shaped by genetics and development and learning, producing inner worlds that are similar in their broad outlines, but often remarkably different in their texture and detail. Slowly, gently, and the dreaming mind, drawing on this deeply personal inner landscape, produces dreams that are perhaps even more individual than the waking experience. The specific palette of your dreams, the particular emotional tones, the recurring faces and places and themes, all of these are an expression of something uniquely yours, a unique configuration of memory and emotion and association that no other person has in exactly the same form. Gently moving forward, let's think about what has been learned from people who have had brain injuries that affect their dreaming. Damage to certain regions of the brain can dramatically alter the content and experience of dreams in ways that reveal how different brain structures contribute to what we dream. Damage to the visual association areas of the cortex, which process complex visual information like faces and objects, can cause people to lose dream imagery entirely, while leaving their ability to generate the emotional and narrative aspects of dreams intact. They report dreaming in a purely emotional or conceptual way, without images. Damage to the frontal lobes can cause a striking change in dream self-awareness. People may lose the ability to recognize themselves as a character in their own dreams. Or they may dream with no sense of self at all, experiencing events without any felt first-person perspective. Damage to certain areas involved in motor planning can cause people to dream primarily of actions, of movement, of doing, with less emphasis on the social and emotional content that dominates many people's dreams. And we can take a moment to notice how precisely the brain's architecture shapes the dream. Remove a piece of the architecture, and the corresponding element of the dream is altered or removed. The dream is not a loose, unconstrained process. It is built from specific neural ingredients, each contributing something specific and necessary to the final experience. And this, in turn, tells us something about waking experience as well. The things we take for granted in waking life, visual imagery, self-awareness, emotional resonance, the sense of agency and movement, these two are constructed from the same neural ingredients. We simply do not notice how carefully they are assembled, because the assembly usually works so seamlessly. Now, let us think for a moment about the relationship between dreaming and imagination. Imagination is, in essence, the brain's ability to simulate experiences that are not currently happening, to visualize things that are not present, to hear music in silence, to feel the texture of something not being touched, to inhabit scenarios that have not occurred and may never occur. And dreaming is, in many ways, the most powerful form of imagination. It is imagination running without the constraints and filters of waking attention. Imagination fully embodied, fully felt, fully believable. The same brain networks involved in imagination are involved in dreaming. The ability to imagine a friend's face and the ability to see that face in a dream draw on the same visual cortex, the same memory networks, the same emotional circuitry. Dreaming is imagination freed from voluntary control, running on its own internal logic, with the intensity that only comes when the critical, editing mind has stepped back. Slowly, gently. And this helps explain something about why imagination can feel so much weaker in waking than dreaming does. When we imagine while awake, we are always slightly aware that we are imagining. The critical mind is present, offering corrections and qualifications, maintaining the distinction between imagined and real. The experience never fully takes hold. In the dream, the critical mind is quieter. The distinction between imagined and real is temporarily dissolved. And the result is experience with the full force of reality, the full emotional weight, the full sensory richness. The dream is what imagination would be if we truly, completely believed it. There is something worth exploring about the theme of death in dreams. Many people dream of death, of dying, of dead people, of funerals, of endings and losses. And these dreams, even when they involve the death of the dreamer, are rarely experienced with the absolute terror that contemplating one's own death while awake can produce. This is curious. Death is, for most humans, one of the deepest and most significant fears. The prospect of ceasing to exist, of the end of this particular awareness and experience, is something that most people find deeply troubling when they think about it clearly and directly. And yet in dreams, death often comes without its full weight. The dreamer may die and continue experiencing the dream from a different perspective, or the dream may shift to a new scene without registering the death as a catastrophic ending. The emotional response to death in dreams is often muted compared to what it would be in waking. And we can take a moment to notice that this may be related to the same prefrontal quieting we discussed earlier. The waking mind's capacity to project forward, to anticipate consequences and extrapolate implications, is what makes contemplating death while awake so disturbing. It is the rational mind that fully grasps the meaning of death. In the dream, without that full projective capacity, death is just another event, just another scene. But there is perhaps also something else here. The dreaming mind seems to have a kind of natural equanimity in the face of endings, a quality that some contemplative traditions would recognize and value. The dream does not struggle against impermanence the way the waking mind often does. Things simply arise, unfold, and pass. Let us think about the phenomenon of shared dreams, or more precisely, about what appears to be shared dream content between people who are closely related or emotionally connected. There are many anecdotal accounts of people dreaming similar things on the same night, of twins dreaming parallel dreams, of people dreaming of a loved one in distress, and later discovering that that person was indeed experiencing something difficult at that time. Science is skeptical of these accounts, and rightly so. Memory is selective, and it is easy to notice and remember the times when a dream seemed to connect with external reality, while forgetting the much more numerous times when it did not. Confirmation bias, the tendency to see what we are looking for, is very strong. And yet the phenomenon is widely reported across cultures and throughout history, and it connects to something genuinely interesting about the social and emotional dimensions of dreaming. There is no need to rush. We know that our emotional connections to others leave deep traces in the brain. People who are closely bonded, who have spent significant time together, who have shared experiences and built deep trust, have neural architecture that is, in some meaningful sense, shaped by each other. Our memories of each other, our models of each other's minds and feelings, our emotional associations with each other, all of these are woven deeply into our neural patterns. When the dreaming brain draws on this architecture, it may sometimes produce experiences that are not literally shared, but deeply resonant. Two people who love each other deeply may dream of each other frequently, may process similar emotional material in similar ways, may come to similar places in their inner landscape, not because they are telepathically connected, but because they are deeply interwoven in each other's neural worlds. Now, gently, let us think about a question that is both scientific and poetic. What is the most recent dream you can remember, and what was in it? You do not need to answer aloud. You do not need to analyze or interpret. Simply, if a fragment comes to you now, a face, a place, a feeling, a color, an atmosphere, let it visit. The content of a dream is, as we have explored, drawn from the materials of a life, from the places that have meant something, from the faces of people who have mattered, from the anxieties and the hopes and the unfinished business of a particular human being at a particular moment in time. And within that deeply personal material, there is the pattern of something universal, something that links this particular dream, in this particular sleeping mind, to the first dream ever dreamed by the first creature whose brain was complex enough to dream. A line runs from that ancient first dream all the way to the dream you will have tonight. Across millions of years, across billions of minds, this same process, this same nightly inner event. Slowly, gently, you are part of something very old tonight. Something that has been happening without interruption since long before your great-great-grandparents were born. Since long before the first writing, since long before the first fire was kindled and the first language was spoken. The dream is older than all of that. Let us think for a moment about the extraordinary things neuroscience is beginning to be able to do. Things that would have seemed impossible a generation ago. Things that sit at the edge of what we understand and hint at what we will understand. Scientists are developing technologies that can decode, to a limited degree, what a person is seeing or imagining from the patterns of activity in their brain. Neural imaging combined with machine learning is making it possible to reconstruct, very roughly, the content of visual experience from brain signals. Some researchers are applying these approaches to dreaming. Very carefully, with a great deal of humility about the limitations, they are beginning to ask, can we see into the dream? Can we decode, even partially, what a sleeping person is experiencing? Early results are very incomplete, very rough. A reconstruction of a dream is nothing like the vivid, precise experience of the dream itself. But the direction is fascinating, and it raises both exciting and sobering questions. And we can take a moment to notice the weight of that possibility. The dream is private, as interior, as personal as anything in human experience. What would it mean if the dream could be seen? What would it mean to be able to share a dream not in memory and language, but in something closer to the experience itself? We do not know yet. We are very far from that capability in any meaningful sense. But the question is alive, and it will not go away. Gently moving forward, let's rest for a moment with the relationship between dreaming and language. Dreams are, in an interesting way, a prelinguistic experience. The primary language of the dream is not words, but images and emotions and sensations. You experience the dream directly, not through description. And yet, when we try to share our dreams, we must translate them into language. And in that translation, something is always lost. The colors of the dreamscape, the particular quality of the fear or the joy, the strange logic that made perfect sense inside the dream, these are very difficult to capture in words. Writers and poets have always known this. Some of the most evocative writing tries to get close to dream experience, to render the nonlinear, sensory, emotionally dense quality of the dream in language. But even the best writing can only gesture at the full thing. And this gap between the richness of the experience and the limits of language to convey it is one of the things that makes dreaming feel intimate and private in a fundamental way. You can tell someone about your dream, but they cannot be inside it with you. The dream is yours alone. There is no need to rush, unless, of course, we think about it from the other direction, from the perspective that all language, all communication, is an attempt to build a bridge between the interior worlds of different minds. Every conversation is an attempt to make one person's private inner experience available to another. And dreaming is one of the clearest reminders of how private and how rich those inner worlds are, and of how much is always left in the spaces between words. Let us think now about the quality of light in dreams. Many people, when asked to describe the light of their dreams, struggle to find the right words. Dream light is often described as different from waking light. Sometimes it has a peculiar clarity, a hyperreal quality, where colors are more vivid and more saturated than anything in ordinary experience. Sometimes the light has a diffuse, sourceless quality, illuminating without any obvious source, casting no clear shadows. This makes sense from a neurological perspective. Dream light is not produced by photons entering the eye. It is produced by the visual cortex directly, by the brain generating visual experience from within. And the brain's internal generator is not constrained to reproduce the physics of real light. It can generate illumination without sources, colors more saturated than any pigment, clarity undiminished by distance. Slowly, gently. Sometimes people describe the light of a particularly vivid dream as being more real than real, as if the dream showed them colors that waking life cannot quite match, a palette that seems to fade and become more ordinary as the dream recedes. Whether this reflects something genuinely different about the dream's visual experience, or simply the way memory processes visual information differently than emotional information, we cannot be entirely sure. But there is something in this description that resonates with many people who hear it. The sense that the dreaming world has a visual quality that is at once impossible and unforgettable. The light of a dream, remembered even years later, that carries a particular weight and color that ordinary light does not have. There is a connection between dreaming and storytelling that is worth exploring gently, because it may go very deep. Human beings are storytelling creatures. We understand the world through narrative. We make sense of our experiences by turning them into stories with characters, motivations, sequences of cause and effect, beginnings and middles and endings. This narrative capacity is one of the most distinctive and powerful features of the human mind. And the dream is a storytelling machine. It generates narratives spontaneously, without conscious direction, from the materials of memory and emotion. It creates characters and settings and sequences of events. It generates dramatic tension and resolution, or sometimes the frustrating absence of resolution. It is, in a sense, the brain's most natural form of storytelling. And we can take a moment to notice that this may not be a coincidence. The capacity for storytelling and the capacity for dreaming may be deeply linked, drawing on the same cognitive machinery. The ability to imagine a sequence of events involving other people, to model their thoughts and feelings, to construct a narrative with causality and meaning. This ability serves us in waking life when we plan and empathize and create. and it runs freely, without external constraint, in the dream. Some scholars of narrative have suggested that the story, the basic structural unit of human communication across cultures and throughout history, may have its deepest roots in the dream. That the first stories were told to describe the inner experiences of the dreaming mind, and that something of the dream's quality, its vivid imagery, its emotional logic, its freedom from ordinary constraint, persists in the best stories ever told. Let us come to a quiet reflection about all the versions of the sleeping self. The you that sleeps is not quite the same as the you that wakes. The sleeping self is less defended, less controlled, less vigilant. The masks and personas that we wear in social life, the carefully managed self-presentations of daily interaction, these relax in sleep. In the dream, the self that appears may be closer to something more fundamental, less constructed. And yet the dream self is also, in some ways, less than the waking self. Less able to reason clearly, less able to maintain continuous self-awareness, less grounded in the stable framework of time and place and physical body that anchors the waking experience of selfhood. Perhaps the truth is that neither the sleeping self nor the waking self is the full picture. Perhaps the self is something that exists across both states, something that moves between them, changed by each, sustained by the interaction of both. The waking self processes and acts. The sleeping self consolidates and dreams. And the fully human person is both held together by the continuity of memory and the thread of body and the long, slow story of a life. Slowly, gently, and in this moment, as the night deepens and sleep approaches, or perhaps has already arrived, you are moving toward that other self. That quieter, stranger, older self. The one that has been with you every night of your life, doing its work in the dark, keeping faith with the long process of being a person. Let it come. There is nothing to resist, nothing to protect against. The dream is safe territory. It is yours. It is old and faithful, and it has been waiting with great patience for you. There is a quiet and important connection between the way we think about dreaming and the way we think about consciousness more broadly that deserves its own gentle moment. When you are awake, right now, reading these words or listening to them, there is something it is like to be you. There is a felt quality to your experience. The words have meaning. The room around you has texture and temperature. Thoughts arise with a particular flavor, a particular tone. This is consciousness. This is the felt quality of being alive and aware. Where does it come from? How does the physical brain, which is ultimately just atoms arranged in patterns, generate something so profoundly non-physical feeling as the experience of being you? This is the hard problem of consciousness, and it is genuinely unresolved. The greatest minds in philosophy and neuroscience and physics have worked on it for decades, and there is no consensus, no agreed-upon answer, not even agreement about how to approach the question. And we can take a moment to notice that dreaming sits right at the heart of this mystery. Because in the dream, consciousness is present without the external world providing its usual anchor. The felt quality of experience continues. Things feel real, feel colored, feel emotionally weighted. And the source of all of this is entirely the brain's own internal activity. Gently moving forward, let us think about how dreaming connects to the sense of time. In waking life, time moves in one direction. The present moment is always the present moment. The past is fixed and finished. The future is open and unknown. We experience time as a river, always flowing in the same direction, always carrying us forward. In the dream, this directionality is much less reliable. Dreams can unfold forward in time, yes, but they can also circle back. They can revisit the past in ways that feel like the present. They can contain, within a single experience, elements from many different periods of a life, brought together without regard for chronological order. The dreaming mind does not respect the timeline. It brings what is emotionally connected together regardless of when it happened. the childhood home and the adult conversation, the long-dead relative and the person you saw yesterday, the old fear and the new situation. Time in the dream is not a river, but more like a deep lake, where things from many different moments coexist and can rise to the surface together. Slowly, gently, this quality of the dream has been noted by people throughout history as one of its most remarkable features. And it is not a defect. It is perhaps a feature. The memory systems of the brain do not store memories in purely chronological order. They store them in networks of association, by emotional connection and thematic similarity, by the patterns they share with other memories. And when the dreaming brain draws on these networks freely, without the linear constraint of conscious waking attention, it can bring together what is most deeply connected, regardless of when it was experienced. Let us think about something that scientists call default mode network creativity and how it connects to the dreaming mind. The default mode network, which we touched on earlier, is not simply a network that becomes active when you are not doing anything. It is a network that specializes in a very particular kind of thinking. Thinking about the self, thinking about other people's minds, imagining alternative scenarios, integrating information across time and context. When the default mode network is active, the brain is doing some of its most sophisticated and distinctively human work. It is constructing narratives. It is modeling other minds. It is imagining possibilities. It is integrating the past and the present and the anticipated future into a coherent sense of who you are and what your life means. And during REM dreaming, the default mode network is fully engaged, fully active, running at capacity, without the competition from task-focused networks that normally constrains it during waking. There is no need to rush. This may be why some people find that the morning after a good full night's sleep, they feel not just physically rested, but somehow more themselves, more coherent, more able to see clearly what matters and what does not, more in touch with their own values and their own sense of what they want and who they are. The dreaming default mode network has been doing its deepest work during the night, weaving the threads, making the connections, and the self that wakes is, in some quiet way, more integrated for having slept. There is a phenomenon worth knowing about called sleep thinking, which is distinct from dreaming but related to it. Sleep thinking occurs primarily in the lighter stages of sleep, stages 1 and 2, and in the brief transitional moments between sleep stages. It involves a more logical, more sequential type of mental activity than the vivid narrative dreaming of REM, but it is still disconnected from waking reality. It is a kind of quiet internal monologue or reflection that continues during sleep, a gentle processing of concerns and questions and unresolved matters. People who are awakened during sleep thinking often report something that feels more like reverie or reflection than dream, more like lying awake in the dark thinking about something than like inhabiting a vivid dream world. But they were genuinely asleep. The EEG shows the characteristic slow waves of sleep. And we can take a moment to notice that the mind, even in its quietest sleeping state, is not entirely still. Even in the lightest sleep, something continues. Some gentle current of mental activity, some quiet thread of the self, persists through all the stages of sleep, maintaining just enough of an inner life to serve as the bridge between the sleeping self and the waking self, ensuring that when you wake as the same person who lay down to sleep. Now, as we continue, let's think about how our relationship with dreams has changed in the modern world. In many ways, modern life is not particularly friendly to the deeper aspects of dreaming. Artificial light extends the waking day well past when our biology would naturally prompt sleep. Screens emit blue wavelengths of light that suppress the production of melatonin, the hormone that signals the brain that darkness has come and sleep should follow. The stimulation of constant media and constant connectivity maintains the arousal of the nervous system long into the night. The result is that many people in the modern world are chronically sleep deprived. Not dramatically, not in a way that feels like emergency, but consistently, persistently short of the amount of sleep the brain truly needs. Cutting an hour or an hour and a half off sleep each night becomes normal. It becomes the baseline. And within a few weeks, the sleep-deprived person has lost the ability to accurately assess how impaired they are. The brain, coping with its own depletion, adjusts its sense of what normal feels like. Slowly, gently. This has consequences for dreaming that we have already touched on. The shortened sleep truncates the long, late-cycle REM periods where the most vivid and emotionally rich dreaming occurs. The emotional processing work, the memory integration, the creative recombination, all of this gets less time, less space, less opportunity to complete. And yet there is something in the human relationship with sleep that seems almost indestructible. Even under the pressures of modern life, even with all the forces conspiring to shorten and fragment sleep, people still sleep. The body and brain still demand it. And when they are given the opportunity, when a holiday or a weekend or an illness provides the space, most people will sleep long and richly, filling in the debt that has accumulated, often with particularly vivid and memorable dreaming in the longer late-cycle REM periods. The body remembers what it needs. The dreaming mind remembers its work. And given the chance, it resumes. Let us come, now, slowly and gently, to consider what all of this might mean for how we live. Not in a prescriptive way, not with urgency or lists of things to do, but quietly, reflectively. We live in a world that undervalues sleep, that treats it as a cost, as dead time, as something to be minimized in the pursuit of productivity and activity and achievement. We stay up too late, rise too early, drink caffeine to override the body's signals of tiredness, and then wonder why we feel fragmented and dull and emotionally raw. What we have explored tonight suggests that this is a serious loss. Not just the loss of feeling rested, though that matters deeply, but the loss of the overnight therapy that processes our emotional experiences and reduces their charge. The loss of the memory consolidation that converts the day's experiences into durable learning. The loss of the creative integration that finds the connections and patterns and insights that effortful waking thinking misses. When we cut our sleep, we are not just tired. We are less emotionally resilient, less creative, less able to learn, less able to regulate our responses to stress. We are robbing ourselves of something the brain works very hard to provide. And we can take a moment to notice, without judgment, with simple gentleness, where we are in relation to this. And the dreams themselves. The vivid, strange, sometimes beautiful and sometimes frightening inner world of the sleeping mind. These are not nothing. They are not mere noise or random activation. They are, the evidence suggests, one of the ways the mind takes care of itself, processes itself, grows and integrates and prepares. Some people feel frustrated that they rarely remember their dreams. They feel they are missing something. And in a certain sense, the waking self is not fully participating in this nightly inner life. But it is still happening. The process continues whether or not the waking mind takes note. The brain is doing its work in the dark and the quiet faithfully every night. Other people are troubled by their dreams, by nightmares, by disturbing content, by the feelings that linger into the day. And this too can be understood with some gentleness. The disturbing dream is often the brain working hardest on the most difficult material. It is not an enemy. It is an attempt, sometimes clumsy and painful, to process what needs processing. Let us now drift into the final part of our journey together. All of what we have talked about tonight, the biology of REM sleep, the chemistry of the dreaming brain, the theories of memory consolidation and emotional processing and threat simulation and creative integration. All of it is a set of partial maps. Each theory illuminates something real about dreaming. None of them captures the full thing, because the full thing is the experience, the actual felt quality of being inside a dream. The colors, the movements, the faces, the spaces, the sudden shifts, the impossible logic that feels true, the emotional currents that can run deeper than anything in waking life. And that experience is one of the most intimate things there is. It happens inside, in the deepest interior of the brain, in the quiet of the night, when the outside world has withdrawn. It is yours in a way that almost nothing else is. Slowly, gently, every night, whether you remember it or not, this happens. This extraordinary interior event, this world being built and inhabited and dissolved, this ancient and universal human experience, this gentle, essential, mysterious process of the dreaming mind. The universe is very old, roughly 14 billion years old, scientists believe. For most of that time, there were no minds to dream. There were no brains, no nervous systems, no creatures capable of experience. The universe existed but was not experienced. And then, very recently, in cosmic terms, on a small blue planet orbiting an ordinary star in an unremarkable galaxy, something extraordinary happened. Matter became complex enough to experience itself. Nervous systems evolved. Consciousness emerged. Minds appeared in the universe. And those minds began to dream. The dreaming mind is, in a very real sense, the universe experiencing itself in a new way. The atoms that make up your brain, the carbon and oxygen and hydrogen and iron, were forged inside stars billions of years ago. They have traveled through space, been part of many different forms, before finding their way into the extraordinary structure of a human brain. And now, every night, that structure of ancient star matter generates an entire inner world, vivid and strange and real, and experiences it. And we can take a moment to notice the wonder of that, the quiet, enormous wonder of that. And as we gently come to the end of our time together tonight, let's just rest with a few final thoughts. Dreams have been with us since before we had words for them. They have been interpreted and analyzed and debated and wondered at throughout all of human history. They have inspired art and religion and science and philosophy. They have brought comfort and terror, insight and confusion, beauty and strangeness. And still, at the core of it all, there is simply the experience. The moment of lying down, of closing your eyes, of letting the day go. The gradual quieting of thought. The crossing of the threshold. And then, somewhere in the deepest hours of the night, the mind beginning its own quiet work, building its own world, following its own patient logic. Slowly, gently, you will dream tonight, whether or not you remember it, whether or not it is vivid or quiet. The machinery will run. The ancient process will unfold. The brain will do what it has been doing every night of your life, every night of every human life, for as far back as we can trace. And there is something very peaceful about that, when we let ourselves feel it. Something very reassuring. The world is complicated, and days are full and sometimes difficult, and there is much to worry about and much to do. But the night is here, and sleep is here, and the dreaming mind is here, patient and faithful, ready to do its work. You do not have to understand it fully. You do not have to direct it or manage it or solve it. You only have to let it happen, to close your eyes and let go of the day and trust the ancient process that is already waiting to begin. There is no need to rush. The light that reaches your eyes right now, if there is any, has traveled. Every photon of light is a messenger from somewhere. The light from a lamp traveled from the heated filament or the excited gas or the jumping electrons of an LED. And before the electricity, before the device, there was the sun. And before the sun, there were earlier stars whose explosions seeded the galaxy with the heavy elements that make planets and lamps and eyes and brains. Everything connects in the end. The star and the sleeping mind, the ancient light and the ancient dream. And you are here, in this moment, at this crossing point of all these ancient threads, resting, breathing, perhaps already drifting toward the edge of sleep. There is nothing you need to do. There is nowhere you need to go. Slowly, gently, let the thoughts settle, like snow falling slowly in a quiet field. Each thought touching down and coming to rest. No need to follow them. No need to hold them. Let them settle. Let the body grow heavy and still. The legs and the arms and the back and the shoulders all releasing into the surface beneath you. Let the breath come and go in its own slow rhythm. Not controlled, not directed, just the natural ancient rhythm of breathing in and out the way it has always been. Slowly, gently, the mind may still be offering thoughts, ideas, memories, small worries, fragments of the day. That is all right. You don't need to push them away. Simply notice them, the way you might notice the sound of wind or rain, and let them pass. You're on the edge of sleep now, perhaps. Or maybe you have already been there for some time. That is perfectly fine. That is the whole point of this. Tonight, somewhere in the deep and quiet hours ahead, your brain will do its work. It will process and integrate and consolidate and create. It will build worlds from the inside out. It will carry you through the strange and gentle territory of dreaming. And when you wake, whenever that is, you will have traveled somewhere. Somewhere real and not real at the same time. Somewhere ancient and entirely your own. Slowly, gently, thank you for spending this time here tonight. For resting and listening and drifting. For letting these ideas wash over you in the quiet of the evening. The science of dreaming is a science of the inner world, of the most intimate and most universal of human experiences. And even when we understand it better than we do now, even when new tools give us clearer views into the dreaming brain, there will still be something irreducibly wonderful at the heart of it. Something that science illuminates but does not exhaust. The dream is yours. It has always been yours. It will come again tonight. Let your eyes close if they haven't already. Let the day go. Let the night carry you. Sweet dreams. If this video brought you some peace tonight, if it helped you rest or drift or simply feel a little quieter, that would mean a great deal. You could very gently, if you feel like it, give it a like, and perhaps subscribe, so you're here for the next quiet journey. But there is no rush. No need to do anything at all right now. Just rest. Good night, and good night.